Now that we've covered the Big Bang mechanism, we're going to get into the how to design worlds recipe. That's a process that lets us systematically design interactive programs, or what Big Bang calls world programs. Now, interactive programs are the most complicated thing we've done so far, and you can imagine that designing them is going to take a little bit longer. In fact, that shows up in the How to Design Worlds recipe because it has two parts. It first has an analysis part that takes place with paper and pencil, and then it has a second part where we actually take the analysis and develop code for it. In this video, we're just going to do the first part, the analysis part. So I really encourage you to get out an actual piece of paper and work along with me through the rest of this video. Here's the problem that we're asked to solve. And I apologize if this is a bit boring, but what we're going to do is we're going to design the catwalk program that we saw as an example in the last video. But this time we're going to design it systematically using the recipe. I'm keeping the same example just to make it easier to focus on the recipe. We'll quickly start doing more challenging interactive program design problems. So what we're asked to do is an interactive program in which a cat starts at the left edge of the display and walks across the screen to the right. When it reaches the right edge, it should just keep going right off the screen. And then this next paragraph talks about something that we're going to add to the program once it's complete. So let's skip that for now. And it's giving us an image of a cat here that we can use. You can, of course, use a better looking image of a cat than that if you have one. So this is a How to Design Worlds problem, and so we want to turn to the How to Design Worlds recipe. Going to the Design Recipes page, the link to the How to Design Worlds recipe is here. And as with the other recipes, the page starts with a summary and then a more detailed explanation. You should read the more detailed explanation after you watch these videos. The recipe says that world program design is divided into two phases, each of which has subparts. And the first part is domain analysis that we want to do using a piece of paper. So the first thing we're supposed to do is draw 2 or 3 pictures that show different stages in the progression of the program. So here we go. Here's what the program might look like at the beginning. We've got the screen, and there's an image of a cat. And there's the little cat's ears, and if you want to, you can make whiskers too. I'm not very good at drawing. That's why I got into computer science. So there's an image of the program early on in its progression. And after a little while, perhaps it looks like this. There's the cat. And later, it looks like this. The cat is kind of in the midst of walking off the edge of the screen. Okay, so the key thing is to draw 2 or 3 images that reflect different stages in the program's evolution and try to capture some of the interesting events. Sometimes you need more than 2 or 3, sometimes you want to zoom in on one. The next thing we're going to do is identify the constant information. So this is information that does not change through the progression of the program. A lot of these values are fairly canonical in the sense that you'll find them in almost every world program, but we still want to identify them. So for example, there's the width of the screen. And what I like to do is label up here what I mean by this. Width is fairly obvious, but they're not all quite as obvious. So there's the width of the screen, there's the height of the screen, what else is there? Well, the cat progresses from left to right, but its height always stays. So the cat's y-coordinate doesn't change. And there's a funny little thing you're going to see here in a little bit, but I'll tell you now, which is the computer scientists, in order to sort of be annoying, have decided that the 0, 0 coordinate in screens is up here in the left, and that y values increase going down. So that's kind of the opposite of the way it works in, for example, grade school. So another constant thing is the cat's y. It kind of sits there at the center, so I'll just call that center y. What else doesn't change? Well, let's see, the background image itself doesn't change. We'll call that MTS. That's the abbreviation that the book uses. It stands for empty scene. And let's see what else doesn't change. Oh, the actual image of the cat doesn't change. So there's some things that don't change. Now, a real important point about this analysis is you should do it in this order, and you should try to identify all the constants. In a complicated program, you're not going to identify them all. You'll realize partway through the process that you were missing one, and that's just fine. Just go back and add it to your list. We're also going to identify the changing information. And in this case, the changing information is fairly straightforward. It's just the x-coordinate of the cat. And the last thing we're going to identify is the Big Bang options. And the recipe page gives us a table that helps us do this. The table talks about behavior that our program has and what options we need to have to support that behavior. So this program has information that changes as time goes along because the x-coordinate of the cat, this value here, changes as time goes on. So that means that we're going to need to use the on-tick option to Big Bang. And this program also has behavior that we see, the display changes. And so that means we're going to need to use the to-draw option to Big Bang. Once we've done that, we've done the analysis for this program. Just to recap quickly, we drew 3 pictures of different states in the program's progression. And then using the pictures, we identified constant information, changing information, and Big Bang options. The constant information inherently will show up in every picture. You may need to use more than one of the pictures to identify the changing information or the Big Bang options. For example, if your program is going to have special behavior that happens when you click the mouse, you may only have one picture that shows that. So Big Bang options don't have to all be in the picture that's above Big Bang options, right? This is really 2 parts of your analysis. One part is the diagrams, and then the other part is these 3 elements of constant, changing, and Big Bang options. In the next video, we'll start converting this into code.